Let us discuss the derivatives of exponential functions. Now, when it comes to derivatives of exponential functions, wherein we will consider two types of base also, wherein the base A, any value A, and base E. So for the first function of base A, which is expressed as y equal to a raised to u, now, the derivative of this function y with respect to x is now equal to a to the u, or a raised to u, then to be multiplied by a constant value of ln of a, and then to be multiplied by the derivative of that exponent, which is variable u with respect to x. Now, when it comes to base e as y equal to e raised to u, then the derivative of this function as derivative of y with respect to x is simply e raised to u to be multiplied by the derivative of u with respect to x. So as for our examples, we have these 6 numbers. So let us try the first example. For example number 1, we have that y is equal to e raised to 3x squared. So we can consider this as our u. And similar with our previous lesson, we can find the derivative of this exponent first. So if our u is 3x squared, then the derivative of this u with respect to x is just simply 6x by means of the power derivative. So bring down 2 times 3 and then less 1 from the exponent. So this is now 6x. And for the given function, the derivative of that function y with respect to x is now equal to, so this should be e raised to u times the derivative of u. So this is just simply e raised to 3x squared, and then to be multiplied by the derivative of the exponent u as 6x. Or we can also express our answer as derivative of y with respect to x is now equal to 6x times e raised to 3x squared. Now, for our next example, y is equal to 4 raised to 3x squared. So this time, if you're going to compare with number 1, this time the base is 4, which is a real number. Now, similarly, it is better to find the derivative of this exponent first, which can be our u, and this is equal to 3x squared. Then finding the derivative of this u by means of power derivative. Then the derivative of this u with respect to x is 6x. And for the derivative of this function y with respect to x is now equal to, this is a raised to u times the ln of a, and then to be multiplied by the derivative of u. So if we will follow that pattern, so this is now a to the u, so 4 raised to 3x squared times the ln of 4, and then times the derivative of u, which is 6x. Or we can also express our final answer as, we can start with the constant value. So this is 6 ln of 4, and then to be multiplied by x, and to be multiplied by 4 raised to 3x squared. So it's better to enclose with a pair of parentheses because this is understood cannot be multiplied with the 4x, as it is better as expressed in product form. So this is our derivative of y with respect to x. For our example number 3, the given function is y equal to e raised to square root of 2x plus 1. Then this time we can consider again that our u, which is the exponent of this function, is equal to square root of 2x plus 1. Or we can also express this as raised to 1/2. Then it is better to determine first the derivative of this exponent u before substituting to the function given as y equal to e raised to square root of 2x plus 1. Then derivative of this u with respect to x is now by simply means of the power derivative. So bring down 1/2, and then to be multiplied by the quantity. Raised to 1/2 minus 1 is raised to negative 1/2, and then derivative of this quantity as 2x plus 1 is now equal to 2. Then multiplying the 2 by 1/2, so this is equal to 1. Then the derivative of this u with respect to x is now simply equal to the quantity 2x plus 1 raised to negative 1/2. Then, as for the derivative of the function y, so this is now derivative of y with respect to x, and this is equal to e to the u. So the exponent is the square root of 2x plus 1 to be multiplied by the derivative of u. So therefore, we can simplify it as the derivative of function y now with respect to x is equal to e raised to square root of 2x plus 1, and then we can express this as denominator to make it positive exponent. So this is over square root of 2x plus 1. For our example number 4, the given function is y equal to 5 raised to x squared plus 3. So our u, which is the exponent of the function, is now x squared plus 3. And then finding the derivative of this u with respect to x is now equal to 2x by means of power derivative. And derivative of 3 is 0. Therefore, the derivative of this function y with respect to x is now equal to, this is a raised to u to be multiplied by ln of a and to be multiplied by the derivative of u. So our given now is 5 raised to x squared plus 3 times the derivative of u, which is 2x, times the ln of 5. Or we can simplify it as that derivative of y with respect to x is now 2 as the constant value to be multiplied by another constant value, which is ln of 5, times x times the 5 raised to x squared plus 3. For our number 6, the function given is y equal to e raised to and then quantity x plus 1 times quantity 2x minus 1. Now, if you want to, you can also multiply or distribute the given exponent. So if we will multiply the given exponents or power of e, this is now expressed as 2x squared by distribution plus x minus 1. Then we can also consider that this time this is our u, which is 2x squared plus x minus 1. Then finding the derivative of this u, this is just simply by power derivative as 4x plus 1. Then for the given function y, the derivative is derivative of y with respect to x, or if you want to, you can also express as the y prime, and this is equal to e to the u. So this is e raised to 2x squared plus x minus 1 times the derivative of u, which is 4x plus 1. Then we can simplify as the derivative of y with respect to x is now equal to 4x plus 1 times the e raised to 2x squared plus x minus 1. For our number 6 example, the given is y equal to 1 over x squared as the power of this e. Then we can consider that the power now will be our u, and this is equal to 1 over x squared, or we can also express as x raised to negative 2. In order to find the derivative of it is just by simply power derivative. Therefore, this is now bring down negative 2, and negative 2 minus 1 is negative 3. So this is our derivative for that u with respect to x, which is negative 2x raised to negative 3. And for our given function, the derivative of it as y prime is e to the u. So this is e raised to 1 x squared times the derivative of u. This is negative 2x raised to negative 3. Or we can simplify it as negative 2x raised to negative 3 to be multiplied by e raised to 1 over x squared.